All right. So, what categories did you use? So, linear versus non. Okay. What else we use? I know at least one person used graphs versus not graphs. They just weren't calling it out right now. What else did we use? There's not right answers here. There's not wrong answers here. I didn't give you the criteria. I just said categories. What'd you use? Equations and non-equations. Versus not. Anybody use anything different? What were you guys using? Linear, non-linear? Okay. Cool, cool. Anybody use anything different? Okay, cool. So, tuck those to the side for a second. We're going to come back to them. And get your little notebookies out. We're going to write in the notebook for the very first time. The little beige notebooks. We're going to go on page 3. Which is like these. Ooh, bouginess.
You said 30?
3. Should look like this. Page 3. We're going to be, it should look like, boop, this. All right. Because what we're going to talk about is we're going to start out by talking about functions. I know you've heard that word before. It's been a minute, though. Do we remember what is a function? This is. I'll put it, zoom it in like this. So we're on page 3. Remember what a function is? Oh, that's weird. Why are the page numbers different sizes? Ew, I don't like that. The odd page numbers are significantly smaller than the even page numbers. And some of them are weird and like doubled. There's 2 page 16s, there's 2 page 18s, there's 2 page 14s. Oh, I love it. That's so much fun. And there's a page 22 next to page 50, so it's going to be an adventure when we're looking at page numbers. All right. Page numbers are an adventure, so we're going to be on page 3 like this. That's fun. I love having fun new activities in my book, like page numbers being weird. All right, so what a function is, that's each input has only one output, or each x has only one y. So the way we're going to define this, and I'm going to have to zoom it in just a minute so my handwriting is not horrifying. So it's a relation or an equation. Usually we talk about a relation, because that could be the relationship between x and y. It could be the relationship between two of those like weird circle things. It could be any number of kinds of things. Where each, oh, come on, there we go. Input, good gravy, this iPad's in a mood today, has only one output. Another way of wording that is to say each x goes to only one y. So each x goes to only one y. Y's can get more than one x, but each x only goes one place. So, I don't like characteristics. So an example of a function, something that we use in real life, is like a vending machine. So I'm going to put that down here. Vending machine. Because if I go to the vending machine and I hit the Mountain Dew bottle, because I'm a caffeine addict, and a Sprite comes out, I'm going to be mad. If I push the Mountain Dew bottle, or if I push the Mountain Dew button and a Sprite comes out, I'm going to be mad because it's not doing what it's supposed to. When I push Mountain Dew is supposed to come out. That's my input is pushing Mountain Dew. My output should be Mountain Dew. If I push Mountain Dew and I get a Sprite, that is not okay. That's giving me a different output. It's giving me more than one output. So vending machines are a function. So instead of characteristics, I don't like that word up here, I'm going to put tests up here. So I'm going to cross out characteristics and we're going to put tests. And the way we can check and see if something is a function. So if we're looking at a graph, that is when we do a very, very fun test with super duper high tech tool known as the super fancy schmancy math STEAK. It's when we get our vertical line test. And you did this back in another one. We see if it ever crosses our graph more than once. So our vertical line test. So if I was to draw a graph down here, so I'm going to draw one down here. Boop, let's say, boop, boop, boop. Something looks like this. If I take my STEAK, I'm going to zoom in so that picture's bigger. Does my stick ever cross my blue line more than one time like this? No. If I had, come on, something like a circle. Does my graph cross my stick more than one time? Yes. So this is not a function, whereas this one is. So these are non-examples, those are examples. Technically, it's two functions because you have to cut it in half and do a domain restriction. Two functions, not a one function. So I'm just dividing it up so it's clear. So this is a function and this is not a function. So on a graph, we do the vertical line test. If we're looking at a table or a mapping, so tables, we know what tables are, and mapping, that's those circle things. And what those are just tables in circles because they be an extra. That's all it is. It's like a drawn table. We're looking for repeats in the x's. So if it's a function, there will be no repeats in the x's or inputs, depending on how it's labeled. And then if we're looking at an equation, it can be written as a y equals. Okay, so when we're looking at the tables or at the mappings, we're going for no repeats in the x's or no repeats in the inputs, because it's labeled as an input on there. On the equations, we're looking to see if we could get them to be a y equals. So if we can write it as a y equals, it can be a function. Now there's going to be some that we can have as functions and not have as functions, and that's a whole other concept, like a whole other dealio. Okay, so we're going to start by looking at functions here. So I want you to take those pink cards back and see if you can sort them into function and non-function. We did a lot of sorting. We found a lot of categories in it. See if you can sort them into function and non-function. So now everyone's going to use the same categories. So check in. So for, we've got our rules up here. Now, zoom in on our tests. Zoom in on our tests. Here we go.
I think you can rearrange this. Take the square root of all of them.
Yeah.
Come on, you got this.
No,
Not quite.
they don't go over the what's Now. Hold on, this one kind of looks similar.
No, you can have re-puts in the output.
I thought that was
This is the function.
Yeah, I'm not gonna try. What causes the vertical line? Because if you put a line through all of these, it would only hit that one. No, it's a function. It causes the vertical line press. It can be negative. That just means that, like, it's decreasing. Each input can only have one output, but an output can have multiple inputs. It's like, you know, like that's a triangle square. Yeah.
Did you say you're photo mapping something? What are you photo mapping? Like honestly, I don't know that photo math would do anything with these.
But it's a line, bro. That crosses.
Does your line only cross at one time? Vertical line test is, does your line only cross one time? Vertical line. Stick of power, stick of truth.
It crosses with.
And kind of a sword. Because why not?
Oh no, it crosses it. The line.
I was just saying, we'll talk through them. Just give it a second.
I see what you did. I see what you did.
To be fair, I didn't actually write them. It comes in the curriculum for the course. Which one? You can make it a function. What shape does that make? As it is right now, we have to put a domain restriction on it. We're not getting into domain restrictions. Extraness. What'd you say? No. What's it from? What's it from, Matthew? Yeah, no, it's not one that's I have absorbed. I have been exposed to many an anime against my will, but that is not one that has been binged in my house. We've binged most of One Piece. I know, but my oldest is currently binging One Piece and My Hero Academia and something else. Can you poke her? Oh yeah. Oh yes. And we've also done a majority of the Pokemons, and he tried, I think tried Yu-Gi-Oh or something. I don't know. There's a couple others that I just absorb through osmosis minor bits of, because they play in the background of my house at full volume. It's okay. You are. What's that? And if you have some that you're not sure, that's okay. Because some of them, it's debatable, or we have extraness. That's my question. Can I write it as a y equals? Here. Okay, so let's look at our functions and our non-functions. What do you have more of, functions or not functions? Functions. So at the top left-hand side are letters. Read me some of your non-functions.
E.
E,
Oh, wait, you said non?
the non-functions. I was gonna s- L. Yep, I agree with you on L. H,
F,
F,
B,
B,
J.
J. Have any others? Anybody else have other ones? I'm not saying this is a complete list. It's just what was called out. I've got B. Yep, as a non-function. D. No, I don't have D yet. I have D over here. I agree. J. Yep, P. 1, 2, 3, 4, 5, 6, 7, 8. I have one other one that I have marked down. What was it? N.
Oh, I'm dumb. I was thinking that
Those are the ones that I have down. And I know there's a couple that were causing some debate. Oh, yeah, sometimes it happens. No, it's very small. They're laminating, cut apart. It's all good. It's all good. I'm not grading your card sort. Okay, so all the others should be functions. Any questions on any of them that we had? That we weren't sure about? Okay, cool. I'm gonna do one more thing, try and get us to catch up because of the snow day thing. Okay, so we're gonna look at the other book. Where's the page number? Look at laughing your books. Ha ha ha. It should be like the next page. We tend to work the pages for the most part in order. Indeed it is. It is page 4. Boop. Which is gonna be, hey, it even has the right page number up here. Look at that. We're probably gonna just base all of our pages off of the even numbers because they seem to actually be in a somewhat logical order. Cool. So, we're here looking at, it's titled journal entry. I don't know why. It is straight up about electrical bills. I know that I sure as heck would never write about an electrical bill in my journal. Because,
They're venting.
I guess,
They're mad at the electrical company.
I guess. Because they want you to write a journal entry explaining how the rate of change can be used in the written scenario. Ew. I very rarely actually do the ridiculousness sometimes that they charge on here. But I want us to see, looking at the table, looking at the graph, and looking at the story, where we could find the rate of change. How could we find how it's changing? What are we even looking for? Because what kind of function is this? And our graph gives us a really big picture. It's a linear. How can we tell that it's a linear kind of function? Because it's a straight up line. I could put a ruler on it and it would match up. Oh, I love that. Thank you. Yeah, let me know if I'm ever writing on something and it's not showing up because I can't see from this angle. All right, so it's a straight up line. So when I'm looking for the rate of change, what piece are we looking for in that line?
Y over X.
Mm-hmm. Which is called the slope. We're gonna look at slope. So starting out with things we know. So we're gonna look at our slope. How do we find slope? If I remembered what I said. That we're looking for slope. It's our rate of change. And then I asked, what is slope? Mm-hmm. That is slope-intercept form, because you're exactly right. We're going to wind up there eventually. Not in this one, but tomorrow. So mx plus b is our slope-intercept. Which of those pieces is slope? M. how do we find slope? We have a little phrase that we usually use. Rise over run. I'm going to zoom this in so I can see right. There we go. We usually do rise over run. If you've done physics, you may have seen it with a triangle piece where we do our triangles. It's the change in y over the change in x. And what we're really looking at here is we're looking at how it's changing our rise. How much does it change up versus how much does it change over? So if we're looking at a graph, we can do it by reading the points. So on this one, we can look at these 2 points. I'm just trying to keep track of time. It's coming out of this table over here too. So we know that the 100 is this point right here, and the 200 is this point right here. We have a few different ways we can find our slope from the table. We can remember that this is my x because it's labeled down here, and that this is my y right here, labeled up here. And we can find the change in my y's by figuring out how it's moving from one step to the other. So what has happened to 20 to get it to be 35 here? What did we do? What about 15? We went up 15. We added 15. I can hear you. You don't have to whisper. Liar. All right, what happened to my x's? How did we get on that same step? What happened here? Take it from 0 to 100. We went up 100, right? We added 100. So I've got my change in y's and my change in x's. So this went up 15 when it went over 100. The change in my y's was 15. The change in my x's is 100. What is that as a decimal? What is 15 over 100? 0.15. If you read through our story, where's a clue in our story about where our slope's going to be?
The charger at consistent.
Yeah, they're charging our consistent rate. And the big clue word I want us to look for when we're looking to try and find slope? Per. Per is almost always, can't guarantee, but almost always with a slope. Sometimes there's more than one thing that'll have per in there because they like to be extra, but most times per is with your slope. Most times. Okay, so we're gonna work a lot with slope and rates of change and comparing rates of change and dealing with how we can make judgments about those and what that tells us about things over the next few days. And we're really going to take kind of a deep dive into slopes and graphs and what they mean in linear functions before we start ramping up into other kinds of functions next month. We'll deal with a lot more quadratics and exponential functions and things like that. But we're really going to deep dive in on slope and linear functions here in this first chapter. So it should all be things that are familiar to you guys, like this, like we're going to deal with lines. A lot. Okay? So if you could bundle your cards together, and if you still have the paperclip, please paperclip them back together. If you do not have a paperclip, I understand they have a tendency to wander off. I have plenty, and I can get you a new one. Where's the box go? And once you get them three bundles, if you put them back in this box on your way out, that would be Sue. I appreciate it. Thank you. And if you need to replace the symptoms of yours that started or ran away, I have some right here. I need the big ones.
You could just listen now.
So you don't have to listen later.
You got your paper clips now. I totally get it, they run away.
Right.
I wish you did that, you guys did for that.
I didn't have to pay that much.